Well, we're in the bush today doing a radio repair. This client's complaining of lack of coverage, and this is the first problem we've come across. An antenna in hard contact with the cab. Arguably the antenna's in the wrong place anyway because of the metal work which is in close proximity to it, preventing it from operating correctly. But that's not the only problem. We'll climb into the cab in a minute and I'll show you how somebody crimped a B and C connector. It hasn't been crimped with a hex crimp at all, it's been crushed with Lord knows what. And we have an expectation of coverage. When we squash the connector that badly, there's probably a hard contact between the center pin and the braid of that coax by virtue of the way that was crimped. So this is the crimping tool that should be used, and as you can see it will crimp a hexagonal shape. Clearly whoever's in my trade doing this kind of thing needs to exit my trade. Of course, if you had the appropriate VSWR meter, or even a multimeter, in actual fact, I haven't tested this one yet, but that's probably a dead short, this problem would show up immediately. Anyway, another one for the rogues gallery. I've replaced that aerial that was down over there with something up here, so there's no metal work within proximity of this antenna, and it'll get a little bit of protection from this boom. I've clamped my bracket underneath this metal plate on the top here by removing these two bolts and then clamping that there. There's a turbo loop there, so if somebody needs to do a repair there's a bit of spare length. And I'm using a CD29 style antenna because this radio currently has frequencies in the forestry band, 150 megs, and it has frequencies in the EEX band, 160 odd megs, and I think the top frequency is up in the order of 170 megs, so there's 20 megs of separation between the 150 meg forestry band and the uppermost frequency in this radio. So this is the most appropriate antenna for that sort of span. Alrighty, here's the existing coax cable going into the cab. This length of cable is now going to be too short, and it's got a brutalized B and C connector on the other end of it. So rather than attempt to do a join, I'm replacing the entire coaxial feeder run, and that way we don't have any external joints for the water to get into. But I'm going to use the existing cable as a hauling cable to get the new coax in. And what I've done is I've stripped the black outer off. I've pushed the coax braid back and snipped the center out. And then what I'm going to do is I'm going to poke the new cable up inside that braid and use the braid to tape the new cable to the old. And when you put tension on it, the braid will attempt to throttle the new cable and get a better grip of it. There we go, that's the end result. So I'll put just enough tape around there to enable that braid to get a grip of the new coax cable, which is between my fingers at the moment, and then we will pull that into the cab. Here's the new cable coming through. You can put quite a bit of tension on that kind of an arrangement to haul cables through awkward situations. And I've just taken the rear cover away. That's the cover that's behind the driver's seat here. And we discovered this. And that's really scary because I've just finished following that round to the battery. It is fused, it's got a 30 amp fuse on it, but it is still connected and the fuse is still in place. And this end's been left floating around loose in here. It's not the first time I found that kind of thing, and it's probably not surprising that we end up with the odd machine catch on fire. I'm going to insulate those ends and pull that fuse out. Right, so we're just crimping up the B and C that's on the end of this coax cable, and I'll put my hex crimper on it and show you what it should look like. I need 2 hands to do this job. Alright, here we go. And that's what it should look like. 6 flats all the way around. Okay, we'll get a either a VSWR meter, a bird through line, or a Anritsu Sightmaster, and we'll sweep that aerial, make sure it's all okay. We'll probably use the Sightmaster. Alright, it's now the weekend and I'm in my workshop at home, and this is the connector we took out of that machine we were working on, and we'll just make a quick test here. First of all, okay, so that's braid to braid and my meter's working. Let's touch this on the center pin. Yep, connectors are dead short. What we're going to do now is we're actually going to carve this open and have a good look at it. More for my curiosity than anything else. The reason for that is 9 times out of 10 in my experience, when the person that makes these connections or fits these connectors, when they don't have the appropriate tool to crimp the braid up, there's an even better chance that they haven't had the appropriate tool to crimp the center pin on. So we're going to have a look, just for the sake of curiosity. Okay, so we've just passed a saw down the side of this ferrule, right the way down the side, and just cut. There's one dodgy crimp in there, there's the other one in that face there, and we just trimmed the side of this ferrule off, and I'll get a pair of pliers and peel this open and we'll have a closer look inside. He's crimped it that firmly I can't get that off of there. I might have to nip the thing apart. It's been that badly squashed. It's proving quite difficult to get into. Might come out of there. And I've just sawn all the way around here, so I can get that off of there, because that's that badly crimped. I couldn't pull it out of the braid ferrule, and I was right, but I was also wrong. I don't know if the camera will focus on this. Oh, is it going to focus? Yes, it is. It is crimped. unfortunately, again, it's been crimped with an electrical connector. It's got auto electrician's connector rather than a coaxial crimper. It's got a big divot in one side, so this is a little unusual, because when I do this kind of thing, I normally find that this center pin isn't crimped at all. I normally find the wire presented up inside of here, and that's all they do. They don't bother to solder it or anything. Okay, so here's the crimping tool. It's got a ratchet mechanism on it to make sure you crimp things right up and do them up to the appropriate tension. So this jaw here, which is a hexagonal jaw, which is labeled 0.213, that's the size that you use for the braid crimp on RG58. And that one there that's labeled 0.068 is also a hexagonal crimp. It might be difficult to see, but it's a hexagonal crimp for the center pin. Now I'm actually very surprised that that particular pin crimped this way even went up inside the connector. Normally the tolerance on the connector is that good that if you don't crimp these correctly, you won't even get the pin up inside the connector. Anyway, if you're doing this kind of work, I can highly recommend you purchase for yourself a hexagonal style crimper. It will pay dividends in the long term. This particular customer, he ended up with incredibly short range, and although the radio hasn't been tested yet, the radio's probably been fried, because when you've got a dead short like this on your BNC connector, if the operator continues to transmit into that dead short, it's normally not too long before the radio gives up the ghost. The final transistor on the transmit side of the radio eventually dies. Particularly if the radio doesn't have some form of VSWR protection to prevent it from coming across this kind of problem. Normally those radios with that kind of protection will either beep at the driver to draw his attention to the fact that he's got an aerial fault, or the radio will automatically turn the power back from 25 watts down to almost nothing. And the reason why they do that is to try and prevent the radio from being killed by exactly this kind of thing. So anyway, get yourself a proper crimp tool. It'll pay dividends in the end.